this video, we are going to study about simplifying radicals and its operations. Before showing some examples on how we are going to simplify radicals, let me first present to you the different conditions on simplifying radicals, most especially if you're dealing with square roots. First, other than 1, the radicand has no perfect square factor. Second, no fractions must appear in the radicand. And third, no radical appears in the denominator of a fraction. Here are the following steps on simplifying square root radicals when the radicand has a perfect square factor. First is, write the radicand as a product of a perfect square factor and another factor. Second, use the product rule for radicals to write the expression as a product of two radicals with the perfect square factor as a radicand. Third, evaluate the radical with the perfect square radicand. Now take note that a radicand is in simplified form when the index of the radical is in lowest possible form. Hence, if the index of a radical and the exponent of the radicand have a common factor, the expression can be written with a lower index. And this process is what we call as lowering the index or reducing the index. We have here some sample exercises on simplifying radicals. First one is the square root of 75x cubed. Take note that for 75, we have a perfect square factor which is 25, and for x cubed, we have x squared. Therefore, we can make use of 25x squared as our perfect square factor. Now, to solve for this, in simplifying, we can write them using the perfect square, the greatest perfect square factor, which is 25x squared, and the other factor, which is not already perfect square, which is x, right? Because that's 2 plus 1, that's still x cubed. And then you may solve them separately, where we can have here the square root of 25x squared times the square root of 3x. And of course, we simplify this, the square root of 25, which is 5, and the square root of x squared, which is x. And just simply copy the other factor, which is not anymore a perfect square factor, so we will just simply copy. Okay, this is the simplified radical for the square root of 75x cubed. Next we have is the square root of 45 a cubed b squared. Now, of course, we have to look for the perfect square factor of 45, which is 9. And then a cubed, the perfect square, the closest for this is a squared and then b squared. And the other factor is 9 times 5, a, because that's a cubed. So that's 8, 2 plus 1, it's a cubed. And then, of course, we solve them separately, or we write them separately para it's easier for us to simplify the square root. Therefore, we have here the square root of 9, which is 3, and then a, the square root of a squared is a, the square root of b squared is b, and of course, just simply copy the square root of 5a. Then we have here 1/2 the square root of 28 x to the power of 6, y to the power of 9. So, of course, we copy the 1/2 because that's the whole number, or the number which is the coefficient which is outside the square root. And then we look for a perfect square factor of 28, which is 4. Okay? And then for x to the power of 6, that is the closest perfect square factor, the greatest perfect square factor, as well as for this one, y to the power of 9, we can have y to the power of 8. And the other is 4 times 7, and the y to the power of 9, so that's 1. 8 plus 1 is 9, and 6 is 6. Therefore, still copy 1/2. And then you separately solve them para it's easier for us to factor or to get the square root of a perfect square factor. And then we have 1/2. Square root of 4 is 2. Then square root of x to the power of 6 is x cubed. 6 divided, it's like 2 here, so 6 divided by 2 is 3. And then for y, 8 divided by 2 is 4. So we have here the perfect square factor of this one. So this is the square root of this. And then the other is just simply copy. And of course, to simplify, you can cancel that. Therefore, our final simplified form of 1/2 square root of 28x to the power of 6, y to the power of 9 is x cubed, y to the power of 4 times the square root of 7y. And we have here our last example. We have the square root of 5x to the power of 7 times the square root of 10 to the power of x to the power of 9. First is you combine them. So it's easier for us to look for a perfect factor for this. So 7 plus 9 is 16. And we can have a perfect square factor of 50, which is 25. And then for this one, the greatest perfect square factor for x to the power of 16 is still x to the power of 16, then 25 times 2. And of course, we solve them separately, the one with the perfect square factor. And then of course, simplify this, which is 5. Square root of 25 is 5, and square root of x to the power of 16 is x to the power of 8. Because 16 divided by 2, it's understood there. By rational exponents, so 16 over 2, that's power over root, which is x to the power of 8, and then square root of 2. There. We have here the simplified radical for this given square root of 5x to the power of 7 times the square root of 10x to the power of. Okay? Now, what if radicals have higher indices? And this process is what we call as reducing radicals to lower index. And how do we do it? Now let's try some of these given examples. The first is, how are we going to simplify the 10th root of 4 raised to the power of 5? So the first step that we are going to do here is to write the given radical in exponential form. So we have here 4 raised to the power of 5/10. Now this is the power over root. And of course, we reduce the fraction, the rational exponent, into lowest term. We have 4 to the power of 1/2, which is in radical form square root of 4. And therefore, our final answer here is 2. So if we really are going to evaluate, the answer for this is equals to 2, and its radical in lesser index is square root of 4. Okay, let's have next example. We have the 4th root of quantity 4x raised to the power of 2. Again, we are going to write it in fractional form, the exponential form in rational exponent. Therefore, we have 4x raised to the power of 2 over 4. And again, simplify it, which is 1/2. And again, write it in radical form, in which we have 1/2, that is square root of 4x. And therefore, the square root of 4 is 2, and the square root of x cannot be simplified anymore. Therefore, we still have to continue. We have 2 square root of x, or 2 times the square root of x. So this is the simplified radical with a lesser index. Okay, and how about if we are going to simplify using one radical simple like this? So first is, again, we are going to write it in exponential form. We have a raised to the power of 12 over 2, and then raised to the power of 1/4. Then we are going to simplify that. We have to multiply 12 times 1 and 2 times 4. We have a 12 over 8, which is, in lowest term, we have a raised to the power of 3 halves, right? Because you will divide this by 4 and divide this by 4. So 12 divided by 4 is 3, and 8 divided by 4 is 2. And when you are going to write it in radical, we have the square root of a to the power of 3. There. So that's the simplified radical for this given example. If you want to have a number with an example with radical and coefficient, so let's try, for example, we have the cube root of the square root of 7. So what we are going to do here is, of course, we write it in fractional exponent. We have here, it's actually the cube root of 7 raised to the power of 1/2, right? Which is the same with like this. We just immediately have 7 to the power of 1/2 times 1/3. Okay? And of course, when you multiply 7 raised to the power of 1 times 1 is 1, 2 times 3 is 6, and therefore its radical form is the 6th root of 7. Okay, so that is if with numerical coefficients, or just simply numerals. Next up is about operations on radicals. In this video, we will just be discussing on addition and subtraction, and we will separate the other operations. Now, for the addition and subtraction of radicals, we can only add or subtract them if they are similar or like radicals. Now, how do we know that they are like radicals? Simple. Just make sure that they have the same index and the same radicand. If not, then you cannot combine them, but just simply copy these 2 or more radicals which are not similar. Let's have some examples. The first one is 4x square root of y plus 6x square root of y. Take a look at their indices. Square root. So we pass the one with the same index, and the radicand is also y. Therefore, this kind of radicals are like radicals. Therefore, we will just simply copy the radicals which are like, okay, and then we will just simply combine. We have here 4x plus 6x, and then just simply copy the square root of y. Therefore, we have 4x plus 6x is equals to 10x and then square root of y. So that's the sum of this given example. Next, we have 5 square root of ab plus 6 cube root of ab minus 2 cube root of ab minus 3 cube root of, 3 square root of ab. Therefore, we are going to apply associative and commutative properties here, combine the like terms, and we apply the distributive property and simplify. We have here let's combine the 5 square root of AB and the negative 3 square root of AB. We are going to put them as 1, and then the other is 6, or we have here 6 cube root of AB minus 2 cube root of AB. Okay, you can interchange this position. That's why it's commutative. And then we are going to solve. So we apply the distributive here. Therefore, we have 5 minus 3, and then the same, which is square root of AB, the common. And then here we have 6 minus 2, and then the common, which is cube root of AB. And then 5 minus 3, that's 2. Then copy the square root of AB plus 6 minus 2, which is 4, cube root of AB. There. So this will be the final answer for this given problem. And the last, if we're dealing now with numerals, so applying the steps when we are going to look for perfect square factors for this until we can find a common radical. For the square root of 80, we have, let's say this is 16 times 5. Okay, and then this one as is for square root of 5, and then this one we have square root of 25 times 5, right? 16 times 5 is 80, and then as is, and 25 times 5 is 125. And if you notice it, we will have here the square root of 16, that is 4. And then stay the square root of 5, and then as is, therefore square root of 5. And then this one, square root of 25 is 5, and then as is inside the radical. And if you notice, we have here square root of 5, square root of 5, square root of 5. Therefore, they are already similar radicals. Therefore, we can just simply use the distributives of 4 plus 4 plus 5. Then, the square root of 5. Therefore, we have here our final answer. 4 plus 4 is 8 plus 5, 13, square root of 5. So this is how you are going to add or subtract operations on radicals. Okay, this is also true with subtraction. You just make sure that they are the same. If not, then as is like this, you cannot combine them anymore. So you will just stop until there. Okay, and of course, we are going to apply this kind of situations also in real life problems. So we have here a triangle, and we are tasked to find the perimeter of the triangle whose sides are these given measurements. Now we are going to find the perimeter. Now, how do we define a perimeter? Perimeter is the distance around a given figure. Therefore, we are going to combine all the distances, and that's the perimeter. In this given problem, we will just simply get the sum of all the sides to find the perimeter of the triangle. And with that, we have here the perimeter. We have the 3 sides. We have 4 square root of 8 plus 4 square root of 18 and 5 square root of 2 centimeters. Now, you cannot just immediately combine them, of course, because they have different radicals. And to do that, we have to change them first into similar, and we can do that because we have here, we can write 4, and then for the square root of 8, that's actually 4 times 2. And then 18, that also has a factor, perfect square factor, which is 9, and then times 2, and then of course as is. Okay, And then we have here 4. Then what's the square root of 4? Which is 2, right? So that's being multiplied. Because if you see like this, that means times the square root of 8. So that's why you use the multiplication here. And then we have as is the square root of 2 that remains. And then for this one, 4 times the square root of 9, which is 3. And then remain ang square root of 2 inside the radical. And as is 5 square root of 2. And then we have here combined. 4 times 2, that's 8. Then 4 times 3 is 12. And then 5 times the square root of 2, which is the centimeters. Okay, in centimeters. So we will have here, our final answer then is 8 plus 12 plus 5, which is equals to 25 square root of 2 centimeters. So this is the perimeter of this entire triangle. 25 times square root of 2 centimeters. Okay? That's it.